Hi folks, and welcome back to Physics with Captain Rod. I'm making this video here to help you out with number 25 in your homework here. And the question basically is this, right? This problem is about this little toy car that's going to undergo this plastic track, and it's going to do this loop deal basically, where the car does this type of thing. And the idea behind the question here is, what speed do we have to have here at what I'm going to call position 1, right? So we've got some sort of velocity vector, maybe we'll call it v1, so that the car can safely make it all the way around the track. Or in other words, it can make it to position 2 without losing contact with the track. Now, what you want to do is start with a free body diagram of the car at that location. And it should only have two forces on it. Now, this car is just sitting on the track. It's not connected in any way, shape, or form. So that should tell you something about the normal force direction on that car. It really can only be one way. Now, in other types of problems, conceivably you could have a normal in either direction. So imagine instead of the car, maybe imagine some sort of bead where there's a wire going through the center of it. If that bead somehow slid up to this position, there are two potential normal force directions in that case. But in this case, there's not. This car is just sitting on the track. Now, the other thing to realize about this problem is the car is accelerating. Look at the velocity vector just before. Let me call that like v1, and just after the final, right? The change in velocity points down, and that should tell you something about the acceleration direction. And hopefully we recognize what type of acceleration that is. When you draw your free body, it should have two forces. Write your Newton's second law equation, and remember my standard rule of thumb, Captain Rod's rules of thumb, I call them carrots. Identify the acceleration direction, call that positive. Write your force equation, right? And it's going to have a normal force in it. Okay, next step. Now we're going to think about the normal a little bit more. If the car were moving really fast at position 2, let's imagine that v2 is a really large number, you would have a very large normal. As v2, you imagine it getting smaller and smaller, ask yourself, well, what would happen to the normal force? And hopefully you'll have a conclusion to that. And then there's going to be a certain speed where that normal is going to go to 0, where the car will start to lose contact with the road. So if you set the normal to 0 in your equation, your v2 is going to be the minimum possible value at position 2 for that car to keep contact. All right, now once you find that, write a work energy theorem between positions 1 and 2. If we put a datum here, there will be no PE1 term. There will, however, be a PE2. You're going to need that height, and a KE2 due to that speed right there. So that should get you through that problem. Just follow those directions kind of verbatim, and it should work out, right? Hope that helps. Have a great day.